All right, so 3.4, example 3, they give us this initial graph and then they want us to change it to this one. So you can see that this is just a root graph, and that's really the only difference. So what we need to understand is that that root sign is the boundary of the function. So when I see this, this 2 is outside the boundary of the function, and all of this is inside that boundary. So it's like where the f would be in a function, that's the same as the root sign. So what we're going to do then is compare this to our basic formula, which would, whoops, let me change colors here, which is y minus k equals a times f, but let's draw, instead of an f, let's actually write it in as a root sign. And then I'm supposed to have b times x minus h under here. So you can see that there's a small problem between this one and this one. This x is a positive, this x is a negative, and there is no set of brackets. So what we can do is factor out a -1. That will make this the same format, and it will make our x a positive. So it solves both problems. So let's start with that. We're just going to adjust this. And all I need to do for that is I'm going to put in a set of brackets and change this sign. Sorry, this pen's not the greatest. But what we've done is we have made it the same value. If I were to multiply through this negative, it would end up being -x plus 3, which is what we had to start with. But now, we could even write this a little more clearly as -1 times x minus 3. Now we have the same format as this one. So we can go ahead and pull our values out. So we've got k, a, b, and h as our values. And we want to look at the positive and negative here. So y minus -1 would work. So k equals -1. A is just a 2. B would be this guy, so that's a -1. And h, it's x minus 3 after we changed it, so h is just 3. X minus 3, x minus h. You can see that h is equal to 3. Right, so now what we want to do is apply that to our table of values. Now our original equation was y equals root x, and we had a couple of points on there. We have 0 and 0. We have 1 and 1. 4 and 2. 1 and 1 would be about there. And if we were to go that far, we would have 9 and 3, because literally it's y equals the square root of x. So what we're going to do is figure out what we have to put into our x minus b plus h, a times y plus k format, which we've got from the previous studies. So we just plug in these values. B is -1, h is 3, a is 2, and k is -1, so it's going to be 2y minus 1. Now x divided by -1 is just going to make x a negative, so we could even simplify this as to minus x, so a -x. Anything divided by -1 is just going to switch the sign. So we plug in our values. Our first one would be, well, 0 and 0, so 0 plus 3 is 3. 0 times 2 is still 0 minus 1, so 3 and -1 is going to be my points there. I take this 1, -1 plus 3 is going to be 2. Take this one, 2 times 1 is 2, minus 1 is 1. Over here I've got 4, so negative 4 plus 3 is going to be negative 1. And 2 times 2 is 4, plus or minus 1 is 3. 9, negative 9 plus 3 is still going to be negative 6. 3 times 2 is 6, minus 1 is 5. So I've got my new set of points here, and I can just graph them on my grid over there. So 3 and negative 1. 3 and negative 1 is going to be about here. 2 and 1 going to be about there. And negative 1 and 3. Negative 6 and 5. I should probably put in some little clips on here. Actually, that one wouldn't be there because these ones are worth more. They've put these each worth 2. So just regraph those last ones. Negative 1 and 3 would be here. And negative 6 and 5 would be up there. So you can kind of see the shape that these things should be between the points. And we see that this was originally half of a parabola. So we can connect these points to kind of reflect that. The last thing we want to do is what is the domain and range of our new function. They don't ask us for the original, so we can just do the domain and range of the new one. So I look at my x and ask myself, what are the limits? Well, there's no limits going this way, but the graph started here. So 3 would be my boundary. X is less than or equal to, because it's coming this way, 3. My range is my up and down value, and I can see from my chart that the lowest range value is negative 1. It's that point right there. So y is greater than or equal to negative